Okay, so we've got a block on some kind of incline. We're not given the angle of the incline, we're just given that if the block travels up the incline by 5 meters, its height changes by 2. Then if it goes up another 5, the height will be at 4, and so on. With these two bits of information, I can get the angle, because sine of this angle is going to be opposite over hypotenuse. This is pretty much most of what we need. Whenever we need the sine of this angle, we can just use 2/5. But I'll go ahead and also calculate theta. Two divided by 5 is 0.4 inverse sine. So theta is about 23.58 degrees. We zoom out. Pen has a hard time close to the edge of the screen. Find the work done for each 5 meters the box moves parallel to the ramp's surface. Work done by the force F. So there's going to be several forces acting on this block, one of which is this normal force, one is gravity acting on it, and an applied force, F. We only have to concern ourselves with the applied force. So the easiest way, how shall we do this? What we could do, we could use a rotated coordinate system. Where straight up and down was the unrotated coordinate system. And the angle is, that angle matches the incline angle. And then we can either write F, we can write F in terms of the new coordinate system, and then the displacement vector in terms of the new coordinate system, or do everything in terms of the old coordinate system. Actually, you know what? Maybe we should do both, just so you can see. Let's see, I'll do in purple the rotated coordinate system. So let's get the vector, the applied vector F, not the total vector, not the total force. This is just the applied force. So the magnitude of this applied force is the 200 newtons. So in the rotated coordinate system, I would have a vector. Okay, so this is going to be F. And I need to project F onto the x prime axis and the y prime axis, or I should say the x prime axis and the y prime axis. So that is in the x direction F cosine theta I hat, but I'm going to put a prime, meaning I'm in the primed coordinate system. In the y prime direction I got a negative F sine theta j hat prime. The displacement vector, we're just talking about 5 meters parallel to the ramp surface. So 5, I'll leave off the units and the significant figures, but it'll be 5 I hat prime. And so the work done by the applied force F is the vector, the applied force vector F dotted into the displacement. That's F cosine theta I hat prime minus F sine theta j hat prime dotted into 5 I hat prime. Sorry about that. Only this term and this term dotted together survives. This term and this term are orthogonal, so the dot product is 0. So we have 5f cosine theta I hat prime dot I hat prime, which is just 1. So this is 5 times 200 times cosine. Yeah, I guess I did need the angle, 23.58 degrees. So that's 1,000 times 23.58 cosine. I get 916.5 joules. Okay, now in black, I'll do it with the unrotated coordinate system. The applied force in that case is simply F in the I hat direction. No primes, because we're using the normal X and Y. And F is just strictly pointing along the X direction. However, the displacement vector would be pointing in this direction, parallel to X prime. So we have to project that in the Y direction and the X direction. We still have theta here. So, oops. Go back to black. The displacement vector in the X component is 5. Right, the hypotenuse was 5 for the displacement. Cosine theta I hat plus 5 sine theta j hat. And now the work done by the applied force. So these vectors are the same vectors, they're just represented in different coordinate systems, or one might say in tech speak, in math speak. We're using different basis vectors or different unit vectors to describe F and S. These F and S are the same as these. I'm just using different ways to describe them. So F I hat dotted into 5 cosine theta I hat plus 5 sine theta j hat. But only this vector dotted into this vector survives. This vector dotted into this vector. Those are orthogonal, because an I and a j are orthogonal. I hat dot j hat is 0. So we have F, that's 200, times 5 cosine 23.58 degrees. I hat dot I hat, that's just 1, and it's the same thing as we had here. So 916.5 joules. I guess with the proper number of sig figs it would be 917 joules. Okay, so what is the normal force between the block and the ramp? Let me draw normal coordinate system, then I'll draw rotated coordinate system. This angle is theta, that angle is theta. I mean, they have to be. That's theta. If that's theta, this is theta. The dot represents the block, and then we have a normal force, the weight, then the applied force, F. So the total force let's write out the total force in terms of the rotated coordinate system, because let me fill, because that's the coordinate system I want to use. Let me make it a solid line. So why do I want to use that coordinate system? For one main reason. The total force is going to have two components. So F total in the x prime direction, I hat prime, F total in the y prime direction, so j hat prime. This component of the total force must be zero. If it's not zero, then that would mean that the block is accelerating perpendicular to the incline. And there's no reason that should happen. If that happened, it'd be weird. And we don't want weirdness. Well, actually, weird physical phenomena is pretty cool. So that's not a good reason. It doesn't happen. If you push something against an incline and you push it up the incline, it doesn't magically accelerate away from the incline. You're pushing it into the incline. I guess you could push it through the incline, but that's not what this problem is even remotely about. So this component of the total force must be zero. So when we add all the forces to get the total force, the normal force plus the applied force plus gravitational force, we need the y prime component to be zero. So let's do the x components first, just because. So n has no x component. N is just the magnitude of n, j hat prime. F we already did in purple up here. So that's magnitude of f cosine theta I hat prime minus f sine theta j hat prime. And then w, well, let's just do it in our heads, sort of, kind of, maybe. So in the x direction, the component is w sine theta, negative w sine theta, since it's pointing to the, towards the left. And the y component of w, negative w cosine theta j hat. It's really cramped over here, so sorry about that. So first the x components, we have f cosine theta minus w sine theta I hat prime. Then we'll add the y components, so that's got a positive n, minus f sine theta minus w cosine theta, all with j hat primes. We need this to be zero, and therefore if n minus f sine theta minus w cosine theta has to be zero, N must be F sine theta plus W cosine theta. And with numerical values, that's F is 200, sine of 23.58 degrees, plus mass of 10, G is 9.8, cosine 23.58 degrees. 1200 times 23.58 sine equals plus 10 times 9.8 times 23.58 cosine equals 169.82. So 170.0 newtons. I'm not exactly sure how to do 3 sig figs when there's a 0 here, but I don't care. I'm not going to look for sig figs on the quiz.